Hey,
Yeah.
you know what I think?
So
I think that my rock would float in the water than your stick.
I think my stick is gonna float, but I don't think your rock's gonna float.
That's wacky, bro. You're wacky.
Let's find out.
Find out. Okay, throw your stick. Come on. Impressive. Now my rock. Edwin, why did my rock sink when there are huge, big cargo ships out in the ocean floating?
I don't know. That's a good question. Let's ask Adam.
Why did the rock sink, but big cargo ships float? It's because of a thing called buoyancy. Buoyancy is how well something floats. There are 4 different parts of buoyancy: weight, volume, displacement, and shape. Weight is how heavy something is. We all know this. But let me ask you a question. What's heavier, a pound of ramen or a pound of sugar? A pound of ramen and a pound of sugar may weigh the same amount, but as you saw, the ramen took up much more space as compared to the sugar. This idea is volume. When something has more volume, it takes up more space. Displacement is the idea of one object pushing another object out of the way. In this case, the ball pushes the water out of the way. It's still the same amount of water, but the ball is now taking up space in the cup. Shape also plays an important factor. In theory, these 2 balls have the same amount of volume. However, this ball with the holes in it allows water to get into the ball, making it less good at floating. This ball has tape over it. The tape prevents the water from going to the ball, making it better at floating. Buoyancy is how well something floats. But the scientific explanation is how much water can displace while still being lighter than the amount of water it displaced. For example, we take this. It floats. Steel. The amount of water it displaces, it is heavier than that water, so it will now sink.
Now, when things flow upwards, we call that positive buoyancy, just like how this bottle went up from under the water. But when we have something that floats downwards, we call that negative buoyancy.
So buoyancy can be applied to everything and anything. That's how we float.
Watch this.
Science! Rules!
You can try this at home. If you exhale all your breath, you too can sink it to the bottom of the pool. Like our friend over there.
Okay, let's break down how all the 4 parts of buoyancy are showcased throughout the video. The weight of an object is a good indicator of how well something is going to float. For example, the still being heavy and sinking as compared to the empty cup. Volume is the size of an object and determines how much water is going to be moved out of the way, or displaced, in order for an object to float, such as the taped ball in the cup displacing water. And even though it is not apparent, when Israel was in the water, he was displacing water, even if the overall water level didn't notably increase. Finally, the shape of an object determines if the volume of an object is going to be used to displace water, such as the taped ball versus the ball with holes. This also applies to Israel in the pool with lungs full of air versus empty lungs. All these concepts apply to more than just sticks, rocks, and cups full of scrap metal. The concepts of buoyancy apply to everything, including large cargo ships.
Oh, okay. So that's why big heavy things like ships float. It's because of
Buoyancy!
science.